And image fundamental is a very important topic because simply when you're dealing with big data, when you're dealing with data analytic master, big data, you're going to deal with images mostly. Okay, images, video, you can find it images on your handphone gallery. I think thousands of images. You get it from WhatsApp and others, and YouTube and Facebook. I think I don't have to tell it. A million of images, and so these images basically are data. Which is basically a data for you to process, to extract the knowledge, information, all those things. The nature of the images basically is different from data you got the bank, the list of name of bank customer. You got the reading of road usage from 1920, 2000 until 2020. How many people use this road? How many car? How many lorry? How many accident happen on those months? So those are different data. So these images are another type of data. Okay, we're gonna look at this data image, and today image fundamental I think it's become very important for you to understand this because today causes is a core is the important concept in understanding the machine learning, or probably the subset of it is deep learning. So when we dealing with image, then directly we will use deep learning. So image fundamental here is very important concept in in uh, in deep learning, convolutional neural network, all those things. Without today course, the concept and fundamental, I think it's difficult for you to follow the neural network and deep learning things. Okay. All right. Let's move on. Okay. And image fundamental. This is what we see as a human. When we are given images, we see this. Okay. So this is the picture of what we see from the image. We see that we got three dogs here. All right. This is what I see. And what you see from this picture. I see three dogs here. Okay. And I guess these three are siblings. Okay. Brother and sister. And they are look very happy dog. I think this is a 1 year old dogs. And I think they are playing on football field. I see a green grass there. So I might be thinking of this is a football field. So this is what you see. So on your right, basically, is what the computer see. So computer see just numbers. Okay, just numbers. I think the best thing is if I close this one for a while, just close this for a while. Okay. All right. So this is what computer see. Computer see numbers. That's why it's difficult to let the computer understand because computer just see numbers here on your right. So what does these numbers represent? Well, it's difficult to say, What computer see they can see numbers here. They can see numbers. If you ask the computer how many 20 are there in this on the screen numbers, they're gonna say there is about 120 20. How many number of 70 in this thing? So computer will easily say there are about 270 in this image, something like that. What is the minimum number? What is the maximum number? What is the average number? How the pattern of the number? That's the only thing computer can do. But basically, what we see this one, I think different there. So basically, this this. If you are given this number without this photo, you're gonna be like the computer. You know nothing. You just know number simply because we see this photo first. Then we said this is represent this photo. Then we understand this photo means a lot. This number means a lot. This number means 3 dogs. This number means 3 sibling dog, 1 years old, happy dog, and so on. You know what I mean? That's the problem, you know, of the semantic gap of multimedia retrieval in technology, computer. Is still far behind. With this number, we couldn't know what is actually, but with this number, then we can see. So basically, the question is how this number produced and what does it mean, basically. That's the important question that we need to ask to learn about. How this number produced and what does it mean. Okay, by knowing this, the architecture of digital image will be easy to construct retrieval system. All right, let's move next. So this is how the image are being captured in real world. Okay, so you got basically you got a camera here, and this is the object, any object, and this is the light. And these are the light and the object are the most two important component because the light and the object, they are combined together in forming the image. So basically the light will make the object either bright, dark, the contrast, illumination, all those things. So light is very important in objects. So the light will go to the object and capture by the imaging system, and they're going to capture on digital medium here. Okay, where in digital medium you got a cell here that contain row and column. So this is how they store. And so let's look how basically the structure of a digitized image here. Right? This is the structure of the image. You have a column. This is column, okay? And you got row. This is row. Row number 0 until row M. You got column 0 until column N. Okay? So this is how they said M and N. So M and N is called M by N resolution. M by N resolution. So the number of, so each of these are called pixel. So each of these are called pixel. So how many pixels are there in this M by N resolution? So you got M and N pixel. You're gonna have your handphone screen or your television. You got high definition. They're gonna somewhere put this the value of M and N. You know, so the more value M and N, the quality will be better. So you got M row and N column, and each has name pixel or pair. So altogether, you're gonna have M times N pixel. And let's say we're gonna have a grayscale image, and say the grayscale image is 8 bits. I think you know hardly hear about the depths. Okay, so the grayscale image, let's say now we consider grayscale image. We have grayscale, we have color image, we have monochrome image, we have binary image. At the moment, let's say we have a grayscale image, and the depth is 8 bits. So what you're going to have is to the power of 8, which is 256 type of gray color. So to the power F, you got 256 type of gray you can choose to paint your photo. And it is all a grayscale. And you got 0 until 255. So altogether is 256 type of gray you can choose to color here. And the first gray, which is white 100%, this is white 100%, supposed to be 8-bit here, 0, 0, 0 up to 8-bit. And 100% black is referred to number 255, 255. And the code basically in binary is 8 bits of 1111. So this is 100% black. You can have in the middle here, which is 50% black, 50% white. So the code will be 177, something like that. 175 code. Yeah. All right. So this is in binary 00. You can change to hexadecimal and so on. So you got this number 255 type of gray. You can choose to paint your photo here. And you consider grayscale 8 bits, right? And so this is color depth. So when you have a 256 color type, so these are grayscale, okay? And we have a 256 type of gray. And if you look at here, okay, simplicity, so this will be this, I guess, because this is the black, 100% black, and supposed to be contain 255. In the pixel value contain 255, okay? And this one, white, I think we consider somewhere around here, okay? Because it's got a white, all right? So 0 here. So that's what it means. So the pixel here, basically you got number 0, mean it is white. And we have m time n pixel. And remember, this is supposed to be color depth, and it's supposed to be grayscale image. Okay. And this value, just now I said, is stored in the pixel to represent the color white. Okay. So these are gonna store in here to represent color white. I think it's not you store it in 8 digit, but you can use it 0 here to represent the whole thing, and put it 0 here inside. When you put 0 inside there, that means it is white. When it is printed on screen, it means white. Okay, so basically, let me see. Okay, and let's say I got 2 by 2 grayscale image, the same with 2 bit. So how many color are you gonna have? 4, yes. So you got 2 the power of 2, it uses 4 types of gray. And that, so basically that gray, basically you can 1, 2. This is number 0. Another one is you got 0, 1 is number 1. You call it number 1. And another one is 1, 1. You got number 2. You call it number 2. Okay, we refer it number 2 easily. We don't say 0, 0, 0, 1, 1, 1. In binary, quite difficult. Okay, so this is number 3. So you got 4 type of color. Okay, let's say on, okay, grayscale with 2 bits. Okay, just put grayscale with 2 bits. Okay, let's see what happened. There you see 2 bits. How many color you got just now? How many color you got? 4 type of gray, which is this is type of color. And the color, the 4 color is basically this one. 1, 2, 3, 4. You only got 4 choice of color as a gray. No more, no less. So this is 2 by 2, right? And if you got images, 1000 by 1000, column and row, you're going to have like this. You're going to have like this. You're going to have like this. So I think this is 8 bit. You see, this is 2 bit. This is 2 bits. Okay. This is 2 bit grayscale. Okay. So this is, you're going to have a look. Okay. So this is 2 bit grayscale. So you got 4 color. Okay. That's the way. And then if you got 1 bit, that means you got 2 type of gray. So you, which is like this. Okay, you only got 1 bit. So only you got only 2 color. So in this case, 2 color, either 100% black or 100% white. There is no in the middle because you only got 2 choice of color, black and white, grayscale. So if you look at this, grayscale is 1 bit. All right. So you're gonna have so 1 bit is also called binary. Okay, the same thing. So this is more than 1 bit. So you got binary image. So the same thing, binary image, 1 bit, monochrome. I think the same name. All right. So you got either black or white, either black or white. 1 bit, either black or white. This is 1 bit, either black or white. There is this is 3 bit. This is 8 bit. Okay, just look like this. So this is 8 bit, 250 tonal level, and this is 5 bits. This is 3 bit, 8 tonal level, 8 type of gray, 32 type of gray, 256, 256 type of gray. So basically, we human we use grayscale 8 bit. So when you're got a grayscale, normally it is in 8 bit. When you say grayscale, you can ask people, what do you mean by grayscale? It is 8 bit, 3 bit, 4 bit. You can ask them. But that's what computer science. But in real life, when we say grayscale, it is 8 bit. Because 8 bits is the nice picture that our eyes can cope. Okay? If you put more than 8 bit, our eyes still the same. Our eyes doesn't catch the difference. All right. So this one, okay. Let's say okay. But normally when you set grayscale, it is 8 bits, and it is column 8,380. All right. So I hope you understand the concept there.
So sorry, just one question. Can you
Yes, yes.
back to previous slide? I mean, the zero value is means fact value, right? Or it can be shift.
Sorry, what is it?
I mean the two. I mean when grayscale value 255 is means white color, or because according to the site is black color.
Yes, I think the
Is
other way
that
around, isn't it? The other way around. Zero
yeah
is black.
yeah? Is that right? Or
Yes.
I mean
I think yeah. I think I make a wrong one. I swap a bit. So zero is a black. 255 is a white.
yeah should be idea. Sorry.
Yeah. We will see
Okay.
later during our
Okay.
during the we're gonna see the content. Yeah, I think you're right.
Okay. Thank you,
So
sir.
it is standard. Zero is a black and 255 is a white.
Yeah,
Okay?
I just curious. Is that can be
Thank
okay?
you. Thank you.
Thank you.
Because we normally use the standard. So zero is black, 255 is white. You cannot change 255 into uh, white and zero into black, because otherwise the picture will be different. Then we need a standardized all around the world. So better we standardize zero is black and 255 is white, and everybody accepted. But you can change if you want, because the code is you can change anything you want. The standard. Basically, we follow the standard. Okay, the standard is like that. Okay, thank you. And all right, now we move to the next. Okay, now we move to the another one is color image. So remember this, we have grayscale. We also can set color image, monochrome, binary, whatever you said. So this only grayscale and color. When you set color image, then it become like this. Okay, this is color image with 8 bit, still the same 8 bit. Remember? So the depth and the name is different. You can set grayscale image with 8 bits. You can say color image with 8 bits. You can say color image with 1 bit, color image with 3 bits, color image with 3 bits, grayscale with 4 bits. If you get grayscale of 8 bits, you have all 256 type of grayscale. But if you have color image 8 bit, you got 256 type of colors you can choose to paint your photo. Okay, just simply like that. What the most important is you have pixel, m time n pixel, and each pixel will contain this number, either 0, 1, or 255. So overall, this number will represent, so this is red, all right? So probably some number red here, the numbers are considered here, all right? And this is yellow, I think somewhere around here, yellow. And it is blue. Blue is 255. In this case, is blue is 255. So normally the pixel here contain 255, the number, and so on. Okay. So this is a bit similar to grayscale, because here you said grayscale 8 bits, so everything is grayscale with 256. And here you got color image and still 8 bits, so you're gonna have 256 color type of color you can choose. Okay. So that's still the same. You call color depth. Color depth is very important. Okay. And normally when we say grayscale in real world, it normally refer to 8-bit. And when we say color image, normally we are referred to 24 bits. Okay. So in real life, when we say color image, automatically it refer to 24 bits. When we say grayscale, normally the image will be 8-bit color depth, majority. Okay. Although they have variant, but majority when you said grayscale, you're gonna have, normally people set it as 8 bits, and when true color is 24 bits. So you don't have to ask your grayscale is what color depth, 4 bit, 8 bit, 6 bit, because the people who use the send you the color are not a computer science, so they don't know, but we assume it is 8 bit depth. So if you got 8 bit, you can have 2 to the power of 24 type of colors. How many there? I think it's million, you know. Very huge number. Very huge number. 224 is a million. But normally they don't put 0 to million. This 24 bits, basically, they're gonna divide it into 3 groups. The first 8 bit is for red, and the another 8 bit is for green, and another 8 bit is for blue. So you're gonna have total of 24 bits for all. Okay. You can have like this, 0, 0, 0. This is 8 bit. Another 0, another 0, 8. So you got 24. Until the end, you got 1, 1, 1, 1, 1, 1, 1, 1, 1, up to 24 bit. So you can have 0 to million. Instead of having that, they chain it like this. They chain it 8 bit, 8 bit, 8 bit. So we consider this a 3 channel. Channel R red, channel green, and channel blue. So they're gonna separate it into channel rather than having one in the whole sum. Okay, got it? So they're gonna have they're gonna divided it the bits into 3 groups. They don't put in the whole lump sum. So another one is red, and then is green, and this is blue. So each of this is called channel. And furthermore, it's still the same color depth. And furthermore, so the 8 bit, basically you have like this. For the channel red, green, 8 bit, it's gonna have 256 type of colors. Green. And another 8 bit, you're gonna have the same thing. Okay. You're gonna have the same like this. Bit of color. And you're gonna another 8 bit here, gonna have the same color palette here. This is reference, you know. This is reference. But basically in real life, in experimenting, if you image processing, you can change this palette. Okay. Whatever, because 0 mean this one, 1 mean this one. So this is lookup table, I think, something like that. Palette, reference table. You can change this if you like. Okay. If you change this, the color will be different then. Right? But they have a standard thing that accepted to everyone. Now, if I have image 2 by 2, okay, by 2 by 2 color image 24 bit. So it means that I got 8 red, 8 green, and 8 blue. Okay, so you got 3. So 8 bits, 8 bits, 8 bits, 8 bits. 8 bit mean you take 8 seed. Okay, so in this pixel you got red, green, and blue. Okay, so here you got numbers, say 10, 100, and here got 2, 2. This is example. You can have like this. So this pixel basically has 3 value. Red, which is 8 bit, green, which is 8 bit, and blue, which is 8 bit. And 8 bit you can represent 10, 100, and 252. Depend on this. 10 here, somewhere here. So what color we look at the lookup table. And 100 is somewhere here. So you're going to have a lookup table. What's 100 represent color? What color? And you got 252. 252 is before this. Okay, somewhere here. Okay, what are color code for 252 and so on. All right. So we're going to move on tutorial of image hands-on on to look at what we have learned just now, the color tabs, the pixel, the value, the RGB, and so on. Okay,